Welcome, doctors, as Mr. Snug almost killed me.
That's it. Okay, and physics 30 in the AM.
I hope that gets posted, and I hope it gets like a police.
Okay, well, there's a school resource officer to talk to with our spinning objects.
I have so many witnesses.
So many witnesses, and you could have gotten your hair tangled in that wheel too. That would have been hilarious. Projectile and circular motion, though. We were doing a demonstration. Anyways, I won't describe further. But what I will is don't write down this outcome thing, but it's from the curriculum, whatever. We're going to analyze the effects of forces on motion undergoing uniform motion. We've kind of done that. Uniformly accelerated motion, kind of done that. Now, circular motion and projectile motion are the other two types we have left. The first thing is that we're going to look at a Mythbusters video and then a haunted, hilarious House of Frankenstein video. And if you're watching on video, I'll just show you what you need to do. Mythbusters, bullets fired and dropped. And then Julius Sumner Miller, 56, HHOF, hilarious House of Frankenstein, projectile motion, Newton's first law. We're going to watch these, but I won't show them because they don't come through very well on the recordings. Okay? So, we watched two videos. We did a demonstration. Now, after the demonstration, I want you to write down what we've seen. It takes the ball the same amount of time to drop straight down as it does to travel sideways and drop. So, that idea. Ball dropped, ball thrown exactly sideways, no downward component when it was thrown. Okay. Jotting this down. I'm going to just slide it so you can see the last sentence. And then that's that. I'm going to pause the video so you can jot that down if you need to. Okay, so we're going to use this fact that it takes the same amount of time to drop straight down as it does to go projectile sideways with this hand forward. So we're going to drop it down and then we have some ABC parts to this. But the first part, how long does it take to hit the ground? And we'll see where we are by the time the bell rings, or close to the bell. I'm going to just draw something that I think makes sense. That's kind of the path the ball would take. Going horizontally. I'm putting this green path as if it was dropped straight down. We're going to consider both cases because one's easier to solve. I'm going to toss this in here. Same amount of time. How long? Like that's a time. We're going to know that same amount of time. Draw 40 meters straight down. That makes the calculations easier to think. So we're only worried about the y-axis. We're not worried about it actually running, going straight, going off horizontal. All we're worried about is the y-axis. I'm putting it in green, because that's what I'm following, this green path right there. That's why I'm putting it green. In the y-axis, we know that the acceleration is negative 9.80 meters per second. We know that the distance is, we're going to call it a negative 40 because it's a dog. We know that the velocity at the start is 0, and time is what we're trying to find. So we're trying to, you don't have to memorize these formulas for high school. You can look it up on those sheets, and d is equal to v1t plus 1 half at squared. I said 1 half at squared, and I didn't write it down. There, 1 half at squared. I'm going to put in our things. I'll put in units after. v1 times t, well, that's 0, so that's just plus 1 half, negative 9.8. And then it's just a walk in the park. It's just algebra. Now I know that I have 3 significant digits, but I'm just getting rid of them. So double negative. Divide that, take the square root. Of 2.866. Okay. Now, 2.86 seconds, and that's whether it's dropped straight down or it's thrown sideways, horizontal. It'll hit at the same time, 2.86 seconds. Now, the next question is the horizontal distance that it travels. So that's my, is that a black or a red tab that I have for now? Black? Yeah. That's what we're trying to find. For this, yes, distance x-axis. I'll call it dx just because of that. And how far from the basin. Okay. You're going to jot that down. We're not actually 3 minutes. We can do that. We can do it because it's fairly simple. Is it being accelerated in the x-axis? We're going to ignore the effect of wind resistance. So, is its motion, is its velocity changing speed? What I'm asking. And if we ignore resistance to wind, no. It's a steady speed. So once there's no acceleration, all of the formulas reduce to v equals d over t or d equals dt. This is in the x-axis. That's 6. Acceleration equals 0. So So we can just use, what was it though? 17 meters per second. So it would be 17 meters per second. And I drew it from left to right, so it's positive. Times by time that we just found. And you notice that the second count.
Judge, please, one quick announcement here before the bell rings here at lunchtime. Just want to remind you that pizza is on sale in Much Hall at noon today, along with some other assorted treats. So again, if you're wanting some pizza, it is on sale today. Thanks so much.
48.6 meters. Now that's where we'll leave off, okay? Velocity was given in the problem.